Okay, so this section of notes is about approximation, right? Approximating area under the curve. So we're trying to approximate it as best as possible. So far we've been working with rectangles, where width or base times height, right? Base times height rectangles, trying to do it that way. There's three ways. There are three methods with rectangles, right? Where are they? LRAM, left ram, RRAM, right ram, and middle ram, right? Rectangular approximation method. The last one we haven't done is for trapezoids, this shape here. Okay, so instead of triangles, we have trapezoids. Okay, it's the same idea though, finding area of each of those guys. But the area is a little different because it's a different shape. So this is the last thing we talked about on Thursday was how do I find area of those? There's a couple different formulas. Base 1 plus base 2 divided by 2 times the height, or 1/2 times base 1 plus base 2 times the height. Either of those will work. Okay, they're both the same thing. Okay, and then here are some of the base 1 is the shorter base. It doesn't really matter. Base 1 and base 2 are interchangeable, but when I say base 1, I'm talking about the shorter side. Base 2 is the longer side, and then the height is actually the width of each of them. Okay. Okay, so they don't give us a graph. I mean, we could graph it. They don't give us a table, but they do give us an equation here. So here we go. So f of x is 6 over x. Okay. If 4 subintervals are used, so 4 subintervals, okay, what is the value of the trapezoidal sum approximation for the bounds go from 2 to 6? The f of x is 6 over x dx. Round your answer to the nearest tenth if necessary. Okay. Okay, so we're going to do it the same way we did it before. The same way we've done it before. There's no difference here. But we have to get more data. Before, like the last couple problems, we just needed the width or the base and then the height, and that was it. Right? Well, now we have two bases. Right? We have two bases, so we have to come up with both of them. Well, we've done that before. What was this called on our other problems? On the other problems we've done, what was this called right here? This side right here. We found it before. What was this called here? Huh? Yeah, but so is this. This is height too, right? So it's not that. What is this? The difference between this and this is what? Look at the other problems we did. Look at the other problems we did. What was this side called? Hmm? Yeah, it's LRAM, right? We've done that before. This side is LRAM, right? The left side, right? This side is RRAM, right? The only one we don't have to worry about is MRAM. There is no MRAM for trapezoids, okay? So we're kind of doing both. We're kind of doing an LRAM and an NRAM together, okay? So the problems we did before, it's the same, it's just together instead of separately, okay? So this is always going to be the same. We're going to try to make this always the same, right? Notice in the question, though, it says 4 equal subintervals, equal length, right? So equal length means they all have to be the same width. Okay. All right. Okay, so how do we set this up? We should know how to set it up by now. It's the last problem we've done. They're all similar problems. If this was RRAM, what would we do? It's the same setup. Nothing's changed yet. Don't wait for me to tell you what to do. Take the reins now. What was the first thing we're going to do? Picture this didn't say trapezoid. picture it said rectangle or LRAM or RRAM or MRAM, what would we do? Hmm? That's what we did first, right? Find the length of each of the widths, right? Good, let's do that, okay? So our, this guy goes from 2 to 6, right? So width of 4, I need 4 subintervals, all of equal length, equal width. So how wide is each one going to be? 4. Or not 4, sorry. How wide is each one going to be? 1 unit. Okay. So let's set this up here. From 2 to 6, f of x is 6 over x dx. So I'm going to have 4 trapezoids, and they're each going to have a height, whichever one you use, it doesn't matter whichever one you use, of 1. Okay. Let's see, let me move it down here so I get a little more room. One, two, three, 4. Okay. And each of them is going to have a width of 1. Okay. Done. So now here I need 2 other things, right? Let's see. Let me get another page. And then I get divided by 2. Okay. So kind of like what Justin said earlier, it's LRAM and NRAM combined. So the first number that's going to be in here is LRAM. The first number that's going to be in here is LRAM. The second number that's going to be in here is RRAM. We're just putting them together since it's a trapezoid and not a rectangle. Okay, so the first one. This might help you too. I didn't do this, and a lot of times students don't like to do this because it's extra work, but it helps me. Draw a picture of the graph. See what you're looking at. It's kind of easier to visualize if you see what you're looking at. It's from 2 to 6. Right? Each one needs to be 1 in length. So 3, 4. Okay. And then at 2, when x is 2, what's the y value going to be for this guy? F of x. Where's the y value going to be for f of x? Mm-hmm. Exactly. What do you get? You get something. You get something nice and round. 3. Yeah. So let's graph that. 2, 3. When I plug in 3, I get something nice and round. What do I get when I plug in 3 to the graph? 2. Okay. 4, I don't get any something nice and round. 4 is like 1.5. And then 5 is even less than that. So I don't need to graph that, but I'm going to graph 6 because 6, when I plug in 6, I get. So the function looks like this. And then it starts here, ends there, sorry. Starts here and ends there. That's the area we have to find under that curve there. The area from the x-axis to f of x. That's where we have to find area under the curve. So our Trapezoids are going to look kind of reflected. They're not going to look exactly like this guy here. They're going to be a little reflected. They're going to look like this instead. They won't fit if we had them like that. Excuse me. They're going to look like this. That's what they're going to look like. So the left side is going to be base 2. The right side is going to be base 1. Okay. Again, it doesn't matter. It does not matter which one's base 1 and base 2. Okay. So if you accidentally plug in the shorter side for base 1 or the longer side for base 1, it doesn't matter because you both get the same. You'll get the same answer for both. Thank you. Okay. So let's look at the first one. Let's look at the very, very first. Let me highlight it. This guy right here. We already know that the width is 1. That's 1 unit. So what's the left base going to be? The left side. How tall is that going to be? It's going to be 3. Yeah, it's going to be 3. 3 units high. Right there. 3 units high. So let's go right down 3 right here. Okay. The next one. The next one is right here. The right side, the right base. How tall did we say that's going to be? 2. Okay. Done with the first one. Next rectangle, or sorry, next trapezoid right here. The height is going to share, the first one is going to share the same as the last one. So that's 2. And then this guy here, how tall is this guy going to be here? One 1.5. Okay. And then the next one starts at 1.5. The next guy here. This is the one we didn't graph earlier because it was a decimal, but it was it's not going to be a whole number. It's 1.2. It's going to be, what was it, 6 over 5? 6 over 5, 1.2. Nice clean decimal, but still, it's a decimal. And then the last one here is going to be 1.2, and then the last one's going to be 1. Okay, hard work is done. Multiply, divide, add. What do you get? So I get 6.670, 6.7. Okay. So that is trapezoid. Again, sometimes for trapezoids, you can see trapezoids, it's a better approximation. So when do you have to do trapezoid? When they tell you to. You only do the approximation they tell you to. Like, I'm not going to do rectangular for this guy here. I wouldn't do it because they didn't ask me to. So you only do what they ask you to. But overall, I would say trapezoid is probably the most accurate out of all of them because it kind of fits the area a little better if there's a curve, especially if there's a curve. Okay. Okay, so I'm going to give you, since that's the only problem we had to do, I'm going to give you one more problem to do. Okay, it's going to be a trapezoid one. I want you to work on the trapezoid one. I'm going to give you one to do. Let me find one real quick, and then you guys can work on it. Find some space on there on your notes or a sheet of paper. Let's see. Okay, so here we go. Actually, you know what? No, that probably won't work. Make this a little bigger. Anytime the question says round to the nearest hundredth or tenth or thousandth or whatever, that means you can use your calculator. So you can use your calculator for this one. Okay. Okay, so if you're still working on it, that's fine. Keep working on it. But I'm just going to get started. So 2 times ln of x, 2 times the natural log of x. That's the function. 3 subintervals, all of them equal width. Okay. It goes from 1 to 9, or 1 to 10. Sorry, 1 to 10. Okay. So I drew a kind of a sketch. I just used my calculator to come up with values. I drew kind of a sketch. That's how natural log looks. Natural log has that kind of look. All logs have this look here. Logs are always going to be positive. Logs are never going to be negative. So it's always going to have that kind of arc there. Okay. Okay. So I have to find 3 subintervals of equal length. Well, my bounds go from 1 to 9. So if they go from 1 to 9, and I need 3 equal trapezoids, what's the width going to be for each? 3. Yeah, 3. Okay. So each of them is going to have a 3. Okay. Okay. So I'm going to kind of sketch them. If you didn't draw the graph, I would suggest for these especially, draw the graph so you can see. It's easy. When you're looking at it, it's a lot easier than actually trying to picture it in your head. So if the width is 3, my first one's going to be right there. It's going to be it's not even going to be, it's going to be a triangle because one of the bases is 0. So if one of your bases is 0 for a trapezoid, it's not a trapezoid, it's a triangle. The next one's going to be here. 1, 2, 3. And then the last one will be here. Okay. So the first one, like I said, it's not even a trapezoid because one of the bases is 0. So one of the bases is 0. This guy here, I have to figure out where it crosses here. for 4. Use your calculator. It's the natural log of 4 times 2, because this is the function here. So you're just going to plug in 4 in here. So when you plug in 4, and then multiply it times 2, you get 2.773. 2.773. Okay, done. The next one starts with 2.773. And then it goes to this guy here, which again, plug in 7 here and it'll get you your answer. And you get about almost 4. It's 3.892. 3.892. Okay. The last one starts at 3.892. And then the last height is here from 10. So the natural log of 10 times 2. 4.605. 4.605. Okay. So if you add all those together, you should get something around 26.901. Something close to that. All right. All right. Okay, so now what I'm going to do is I'm going to give you some time to